Hello everyone and good afternoon to all of you. Today we have a problem which name is restore the array from adjacent pairs Leetcode 1743 problem. So before going forward in this video, please make sure that you have liked and subscribed to this channel, and also it's my advice to all of you that please read the problem carefully and try to do the code. At least try to build up the intuition and do the code. If you are beginner, then you can see directly because it's a quite bit little bit hard problem is. So let's see the problem. What problem is saying that we have there is an integer array nums that consists of n unique elements, but you have forgotten it. However, you do remember every pair of adjacent elements in nums. Okay, you are given 2D integer array adjacent pair of size n minus 1 means we have given the adjacent pairs. Okay, so where each adjacent pairs of I equals to ui comma vi indicate the element of ui comma and vi adjacent in nums. So can you take the field of graph? Now you will take the field of graph. It is guaranteed that every adjacent pair of elements nums I and nums of I plus 1 will exist in adjacent pair. Okay, this line is important. Okay, either as nums of I comma nums of I plus 1 or nums of I plus 1 comma nums of I. It means it is a undirected graph. You can take the field. It can be nums of I to nums of I plus 1 or nums of I plus 1 to nums of I. Can you take the little bit feel of graph? Because by reading this statement, you can easily think about graph and undirected graph also. The pairs can appear in any order. Okay, so return the original array nums. Okay, we have to return the nums. There can be many answers, multiple answers also. So we have to return any of them. Okay. So let's see the example. We have given 2 1, then 3 4, then 3 2. So let's see. If I am taking the starting element as 1, okay. So 1, I can take the adjacent element of 1 is 2. So it will be 2. The adjacent element of 2 is 3. So it will be 3. Adjacent of element of 3 equals to 4. So it can be 4. So it can also be if I start from 2. Okay, let's see. Here this. Okay, if I start from 2, so it can be 2. Then adjacent pair of 2 will be 1. Then 1. Then adjacent pair of 1, nothing. So I can do and nothing. Okay. So if I start from 3 4, so it will be 3 starting element. Then the adjacent element of 3 is 4 4. The adjacent element of 4 is nothing, so I can do nothing. So there can be multiple answers, so you have to make that. Okay, so let's see the intuition part and approach part for this. Okay, if you didn't read the problem till now, so please read the problem. Okay, then you can understand better. Okay, so let's see the intuition part. Yeah, if we have elements a b c d, okay, we have given these elements, so there's the connections. A is connected to b, b can be connected to a. Okay, that is not a foundation for us. Okay, c is connected to b and b can also be connected to c. So it is I already showed you that it is an undirected graph, so no need to worry about this. Okay, it can be ab or ba. Okay, C is connected to D. So the way of making, see, the way of making is if I start from D, I am taking the element of D, starting element is D. Okay. So adjacent element of D is C, then I can take C. Then adjacent element of C, here is B, so B. I cannot take the adjacent element of C is D because D is already there, so I can take B. Okay, the adjacent element of B is A, so A is a A. If I start from A, okay, I am starting from A. So I am starting from A. The adjacent of element of A is B. Then it will be B. The adjacent element of B is C, either C or A. So A is already there. So C will be the adjacent element. Then D. So this is my connected like this. But as you can see, middle elements are same. Here the middle elements are same and middle elements are. However, the order is different. If you reverse them, ABCD, if you reverse this, then our answer will be this. Okay, so I am taking like this A B C D. Okay, so as I have already told you that here I can use graph because as you can see, here's an undirected graph. A is connected to adjacency list. How we can make the adjacency list? Means what is the mean of adjacency list? The mean of adjacency list is A है मेरे पास एलिमेंट, उससे कितने एलिमेंट कनेक्ट है. मैं अनडायरेक्टेड ग्राफ की बात कर रहा हूँ, ना कि डायरेक्टेड की. डायरेक्टेड में भी डेफिनेशन सेम होती है, बट डायरेक्ट उससे ही कनेक्ट होना चाहिए. अब इससे क्या है कि अनडायरेक्टेड में क्या है कि अगर मेरे पास ए है तो ए से कौन कौन से एलिमेंट कनेक्टेड है, ओनली बी. बी से कौन कौन से एलिमेंट कनेक्टेड है, ए और सी. लाइक आई हैव रिटर्न दिस आल्सो. एंड सी से ऑल कौन कौन से एलिमेंट कनेक्टेड, बी और डी. एंड डी से ओनली सी. सो हाउ वी क्रिएट द adjacency list? Now you know. Okay, नाउ मीन्स अपन को जो भी कनेक्टेड एलिमेंट है ना उनको लिखना है. जैसे ए से कौन कौन से एलिमेंट कनेक्टेड है, फिर बी से कौन कौन से एलिमेंट कनेक्टेड है, वो उसको लिखना है. देन नाउ यू कैन सी there the length of adjacency list either can be 1 or 2. If it is the 1, the length is 1, it means it can be the starting element or ending element. Now as you can see the length if a is there, so starting element of a means length of a, it means the connected elements, because the left side there is no element and right side there is only one element, so length is equal to 1. And also same is here. Okay, length is equals to 1. And if I take the middle element like b, so the adjacent elements is c or a, the length equals to 2. So like this, the middle element, if there is a middle element, so length is 2. Or if length is 1, it means it is a starting element, okay, or ending element. Okay, if my I will create like this. Okay, if my new array length means new, कुछ वेक्टर में तो स्टोर करूंगा ना. So if my vector length equals to graph length, okay, then I will stop. Okay, so what you now know that we will create the adjacency list. What why I'm telling adjacency is it's adjacency. Okay, actually I have to take a water. So it's a adjacency list. So as you can see, finally I have to return the whole vector. Okay, so I will return the it. Okay, if my vector size equals to the graph size, I will stop. Okay, so let's try to do the code. Okay, so please, it's my advice to you that please make like this. Okay, please create the adjacency list because it is necessary to create. Okay, so let's do. So what I will do, I have to create the adjacency list. So adjacency list. So how I will create the adjacency list? I have to create another में. इतना तो उसमें ग्राफ में पड़ा होगा ना, वही है वेक्टर int graph. I'm like this. I'm writing like this graph. Okay, and also I have to create the answer vector because finally I have to return the answer. Na? That's why I'm creating the answer vector. Now what I'll do? I will traverse whole auto I belongs to this adjacency pairs because मेरे को create करना पड़ेगा ना adjacency list को. So how I will create? So graph of I of 0 because it is a directed graph. So I'll write like this graph of I of 1, and same is here. So let's copy this. It will be 1 or it will be 0. So now we have created our graph. Now what I will do, I will create uh, I will create our adjacency means I have created the adjacency list. Okay, now what I will do, I'll check. Okay, if the element is starting element of mid or middle element. If the element is starting element, the length will be 1. Okay, so what I will do, I will check for auto I belongs to again this node pairs. So now, no, it will be graph because we are traversing the graph. But we are taking an element and we will check the length is one or not. Okay. If my answer, if what I will do, if okay, I have created the graph. Okay. So I'll check our first element is integer like a. The adjacency list of A equals to B. A is equals to B. So B is in vector. So I'll check if I dot second dot size. Okay. Second dot size is showing equals to 1. What it is showing? It is showing this. Let's see. If my adjacency list of A to B. So it is showing it is an integer element or it even vector because AC or BD how we can store. So I have written the data structure vector. Okay. So it is showing I dot second dot size. It means B. If size equals to 1, yes, size equals to 1. Now what I will do? I'll check. I will push the elements. So answer dot push back what I will push. Let's see what I will push. The integer element a. So I dot first. Or now what I will push. So let's see. I have already told you that you need this. Okay. If you have this, then you can create this code also. Okay. So you have to make this. Okay. So I have written this, and I have pushed this answer dot push back of what I will push I dot first. No, I dot second also because A is connected to B. So A is our element. So I have pushed this A. Okay, now I have to push the B also. So B of 0 means starting element. Okay, this is done. Now what I will do? So I have to, this is done now. So I have to break this here because this is the first element where I am pushing the in vector. Okay. So what I will do now, I'll check for middle element. Okay. While answer dot size, I'll check for middle elements. So while answer dot size is less than graph dot size, if the answer dot size equals to graph dot size, so I have to stop there. So this is done. Now what I will check in this, I'll check if I'll take an element, okay, previous element or current element. Int I can take last previous equals to answer dot size minus 1 or 2. If I'm taking the previous element, if let's take the previous element. So what I will check means per previous element. So it will be minus 1. So I have to take this like this. Okay. Or int last current equals to answer of answer dot size minus 2. Done. I know this code seems to be hard, but it's it's you have to do this means it's there also. So this is done. So what I will do, I have done this part. Now I have to traverse from the neighbors. Okay, so I have to create a vector VOUR. Okay, neighbors. equals to graph of graph of what last current. I will explain. Okay, last current. Now what I will do, I'll check if what I will check now. Let's see if neighbors of 0, NEIGHBOUR of 0. Let's copy this. It will come further in the video. So let's copy neighbor of 0 not equals to what? Not equals to the last previous element. If the I will explain. Okay, last previous element. If that number is not equals to last previous elements, so what I am doing is, if see, I'll say how I will create this. I'll take element A, that is if length equals to 1, that condition. So I will take a element A, or I will I'll push this in answer, or I'll also push this in answer. So A and B is corrected. Now I will check the adjacency nodes of B. So I'll check A. A is there. Yeah, A is there already. So I will means I will close this, and I will check here if C is there. No, C is not there. So add this. Okay. Now I'll check for C. If B is there, yeah, B is there. So I disclose. Let's close this topic. Okay. And if D is there, D is not there. So D will connect. Okay. Let's see if that element is already present. I will not take. If that element is not present, I'll take. Okay. So that is I am doing. Okay, last previous. So what should I do? I will push that element answer dot pushback of that neighbor of I, means let's copy this neighbor of 0. So I have pushed this element in answer. Okay, so now what I'll do, in else condition, if at element equals to the last previous element, that previous element, so what I'll do, I will simply push the element answer dot pushback of that particular neighbor. So neighbor of I1 means. So this is done. So finally, what we'll do? We'll return our answer. Let's see if this will work or not. It is giving runtime error. Okay. So let's see what